in this lesson and in the next few lessons we're going to look at combustion reactions. Now, when a combustion reaction takes place, a substance reacts with oxygen. In common everyday language, this is known as burning. Okay, we say that this substance burns. Now, whenever we think of burning normally, we think of things like paper or wood or coal or petrol. In other words, we think of fuels. But lots of other types of substance also react with oxygen. For example, metals will react with oxygen and in fact burn in oxygen. Now, if I were to take a lighted match and place it underneath this fork, you know very well that the fork wouldn't catch fire. The reason for that is that the heat from the flame of the match is very easily dissipated by the fork. It spreads through the fork, and the fork actually doesn't really get hot enough for a chemical reaction to take place. However, if I put the flame underneath this steel wool, so we have steel wool, right? That's basically really iron, and a steel fork. If I place the flame under the steel wool, then the strands of wool will get very hot indeed, and in fact they get hot enough to kickstart a burning reaction in which the iron in the wool reacts with oxygen, and you can see a video of this in the practical demos section. So iron is a metal and it reacts readily with oxygen, providing that the conditions are correct. All right, you won't get a great big lump or chunk of iron reacting with oxygen, but you will get tiny little strands of iron reacting. So let's have a look at the general equation for this reaction. We say that a metal plus oxygen will react to form a metal oxide. So that's the general word equation, and it's fairly straightforward. Okay, so in this particular example, you have iron plus oxygen reacts to form, in this particular case, iron 2 oxide. Now there are two types of oxides of iron. One is iron 2 oxide and another one is called iron 3 oxide, which you're more familiar with, and that is also known as rust. Now we'll deal with that in a later lesson when we look at tarnishing. Okay, so metals react with oxygen. Okay, so what we should also do is write out the symbol equation. Okay, remember that iron has a symbol Fe, and oxygen as it exists in the air around us is a diatomic molecule, so we write O2, and that's going to form iron 2 oxide, which has a formula FeO. Again, you see that this equation isn't balanced. There are two oxygens on the left, but there's only one on the right, so I have to put a 2 here, like that. Now I have two oxygens, but I also have two irons, because that 2 refers to all of the atoms to its right. Okay, so I have to put a 2 here to balance the equation. Okay, now we'll have a look at another metal. This time we'll look at magnesium, which is a much more reactive metal than iron, and again you can see this reaction in the demo section. What we do is we take some magnesium chippings, right, little grains of magnesium, not quite magnesium dust, but they're grains of magnesium, and what we do is we heat those grains in a Bunsen burner, and then as soon as the magnesium starts to burn, let's say it reacts with oxygen, then we immediately put it in this gas bottle. Now this funny shaped spoon that you can see, which is joined on to the lid, I believe is called a deflagration spoon, and I suggest that you call it a burning spoon. I've also seen it referred to as that, so call that a burning spoon. You know, and the reason why you do this really is because you don't want to be inhaling fumes. Oops, spoon. You don't want to be inhaling fumes when any substance is burning. Okay, so we allow it to burn, and what you'll see is that a white powder is produced. Okay, as the magnesium burns, you get a white powder, and that white powder also condenses on the surface of the gas bottle. So what is that white powder called? Well, magnesium's just reacted with oxygen, so it's going to be called magnesium oxide. We can write that equation out again. We'll write the word equation out. Magnesium plus oxygen gives us magnesium oxide. All right, and because magnesium is a much more reactive metal than iron, actually you'll notice that this burns with a very, very, very intense and bright flame, which actually dazzles the eyes, so you need to be careful with that. Magnesium is used in the manufacture of fireworks for this purpose, and also in the old-fashioned camera flash bulbs. Right? It produces an enormously bright light when it burns in oxygen. And we can write out the symbol equation for that. Magnesium plus oxygen. Just repeating again, if the gas is an element and it's not a noble gas, then it will be a diatomic molecule. So that gives us magnesium oxide. Again, you might want to write that there because it's balanced, but you're not allowed to do that because the formula for magnesium oxide is not MgO2, it's MgO. So that means we've got to balance the equation. Again, as with 4, we've got 2 oxygens there, 1 there, so we write a 2 next to the magnesium oxide, but that refers to the magnesium and the oxygen. So now we have 2 atoms of magnesium, then we need to place a 2 here. Everything's fine, the equation's balanced. Now then, I want to say something important which in regards to most metals, okay, is that when they burn in oxygen they produce an oxide. When we take that oxide and add it to water to form a solution, then that solution will be in general an alkali. So if we take magnesium oxide, right, this white powder that's formed here, and then we form a solution, and we do this in the video, we add it to water, and then you test the pH of the solution with litmus paper, you'll notice that it goes a kind of darkish greeny blue colour, which tells us that the solution is an alkali. In fact, the name of the solution is magnesium hydroxide. Okay, so we form a solution of magnesium hydroxide, and as you know, anything which is able to provide hydroxide ions in solution is an alkali. So this is an alkali. Okay, and we can make a general statement. It's not true for absolutely all metals, for just about most metals you can say that the oxide of a metal is alkaline. Okay, so we say metal oxides, alkaline solutions when added to water.